Hey guys, welcome back. In today's session, we are going to understand what are instance variables, instance methods, what are class variables, class methods. Let's begin. File, new, Java. Class, car. Inside, int, speed, comma, gear, boolean, clutch, brake, accelerator. I declare these variables and I give couple of methods. Public void start, public void stop. Now let's have a look at these variables. If you see these variables, where they have been declared, they have been declared outside a method. Outside a method. You must be knowing that variables can be declared inside a method also. If we declare variables inside a method, what are those variables called? They are called local variables. Local, if they are declared inside a method. But in this case, if you see, they are not declared inside a method, they are declared outside the method. So what are these variables called? Most students call them global variables. So let me tell you, global word not used in Java. Local word is used. If you declare variables inside a method, in Java also, they are called local variables. But if you declare variables outside the method, in Java, they are not called global variables, they are called instance variables. Instance. So speed, gear, clutch, brake, accelerator, in our case, they are instance variables. Let's try to justify why are they called instance variables. Let's try to justify why the name instance variables. If you see here, I write one more class, public class test car. Inside, I give a main method, public static void main string args square brackets. Now inside this main method, first car C1 comma C2. So I declare two variables C1 C2 of type car. After this, C1 is equal to new car. C2 is equal to new car. I create two objects, two instances. An object is an instance of a class. I'm creating two objects. I'm creating two instances. Let's do one more thing. This speed variable in car class, let's make it public. If I make it public, anyone from outside will be able to access the value of those variables, as well as he will be able to assign values to those variables. I make that speed public. Now again, come back here. I just created two objects of car class. Now, since that speed is public, I can directly assign a value to it. C1 dot speed is equal to 100. C2 dot speed is equal to 200. Okay. C1 dot speed is equal to 100. C2 dot speed is equal to 200. Now, system dot out dot println C1 dot speed. I access speed variable of C1 and I print it. Just think, what do you think is the value that he's going to print? Just think. If your answer is it's going to print 100, you're 100% correct. The value that it's going to print is 100. Okay. Now, since it's going to print value 100, we actually justified why that speed variable is called instance variable. Now try to understand why it's called an instance variable. How many instances we created? Two instances. 1, 2. Every instance has its own copy of speed variable. Every instance has its own copy of speed variable. We have created two instances, two objects of car class, two instances. C1 is referring to one of them. C2 is referring to other instance. This instance has its own copy of speed variable. This instance has its own copy of speed variable. When I say C1 dot speed is equal to 100, I am setting the value of this variable. When I say C2 dot speed is equal to 200, I am setting the value 200 of this speed variable. Every instance has its own copy of that variable. Similarly, when I system.out.println C1 dot speed, I am accessing value of this variable and printing it. Every instance has its own copy of that speed variable, which belongs to that instance. This variable belongs to this instance. This variable belongs to this instance. Every instance has its own copy of that variable, which belongs to that particular instance. That's the reason they are called instance variables. So, you know, all those variables, speed, gear, clutch, brake, accelerator, all those variables, they are called instance variables. Why? Because for every instance, there'll be a separate copy of those variables, and those copy of variables will belong to that particular instance. That's the reason they are called instance variables. Belong. So like here, this is speed variable. This is speed variable belongs to this instance. Now tell me, if we don't have this instance, will we have this instance variable? If we don't have this instance, will we have this instance variable? No, because it belongs to him. So if this guy is not there, if instance is not there, instance variable will not be there. So if instance is not there, instance variable will not be there. And if instance variable is not there, how can we access it? We cannot access it. So to access an instance variable, you need an instance. And when you have an instance, how do you access an instance variable? Reference to that instance dot. Reference to that instance dot. That is how you access. So keep one thing in mind, that to access an instance variable, it is necessary, it is a criteria that you should have an instance. If you don't have an instance, you cannot access instance variable, because if you don't have an instance variable will not be there. So how can you access it? You cannot access it. So quickly repeating, every instance has its own copy of that variable, which belongs to that particular instance. That's the reason they are called instance variables. If instance is not there, instance variable will not be there. If instance variable is not there, how can you access it? You cannot access it. So to access an instance variable, you need an instance. And when you have an instance, how do you access an instance variable? Reference to that instance dot. I hope it justifies why they are called instance variables. At the same time, I'd like to give you more knowledge. Okay. When we defined constructor, remember, constructor is a special type of a method which has name same as that of class name, does not have a return type, is called only once during the life cycle of an object. In fact, to instantiate an object, what is the last point? It provides storage space for the variables. Which variables? It provides a storage space for instance variables. Remember this. So now let's be more clear. Rather than saying constructor provides storage space for variables, it's better we say constructor provides storage space for instance variables. Now in our case, we are creating two instances of car, two objects of car. If you see here, C1 is equal to new car, new followed by call to the constructor. As soon as at runtime, this constructor will get called. It will provide storage space for speed, gear, clutch, brake, accelerator. So these copy of variables got created. Now these copy of variables belong to this particular object, this instance which we created. Similarly, when we create another instance, C2 is equal to new car, again that car call will go to the constructor of car. Again, as soon as at runtime that constructor gets called, again he will create he'll create speed variable. He'll provide storage space for speed variable, speed, gear, clutch, brake, accelerator. So now these copy of variables belongs to this instance. So this copy of variables is of this instance. This copy of variables is for this instance. Every instance is having its own copy of these variables. And mind you, when are they getting created? When are these variables getting created? When you are creating an object. When you are creating an object. So in case if you don't create an object, if you don't create an instance, these variables will not be created. If these variables are not created, how will you access them? You cannot access them. So to access them, you will have to create an object. You will have to create an instance. I hope it justifies. Okay. I hope it justifies. Okay. That's the reason they are called, in fact, that's the reason they are called instance variable. In fact, in memory, object in memory is what? What is object in memory? This block of memory, this block of memory with these 5 variables, this block is what is object in memory. That's it. Okay. That's it. So I hope this concept of instance variables is clear. Every instance has its own copy of that variable which belongs to that particular instance. That's the reason they are called instance variable. If instance is not there, instance variable will not be there. If instance variable is not there, how can you access it? You cannot access it. To access an instance variable, you need an instance. And when you have an instance, how do you access an instance variable? Reference to that instance dot. Also, mind you, who provides the storage space for instance variables? Constructor provides the storage space for instance variable. As soon as runtime constructor gets called, that constructor will create storage space for all the instance variables. So when an object is created, that object's copy of variables, copy of instance variables gets created. So means you can access an instance variable only when you create an object. If you don't have an object, you don't have those variables. If you don't have those variables, you cannot access them. That's simple as that. So that was the explanation about why those variables are called instance variables. Similarly, okay, these methods that you define in the class, they are called instance methods. They are called instance methods. Now, why are they called instance methods? Why are they called instance method? Let's try to justify. Now what I do, I make this speed private. And as idle OOP tells me, if you want someone to access as well as assign, declare the data as private, provide a public interface to the private data, give 2 methods, one to access the value of that variable, one to assign a value to that variable. So I am now keeping that speed private, and I'll give 2 methods, one method to access the value of that variable and one method to assign a value to that variable. Public return type int, name of the method get speed, return speed. Okay. This is a method to access the value of speed variable. Similarly, I give a method public void set speed. Okay. Takes parameter int I inside speed is equal to I. Okay. Speed is equal to I. Even before that, we did not see the result of this one, printing 100. Am I right? I'd like to first show you that it prints 100. So just a moment. We'll again just put this in comments, this setter getter. Okay. And here, again, make it public. Just first I'll show you that it prints 100. We discussed that it will print 100. Okay. We'll have to save it by the name test car because our test car class is public. So I'll have to save it by the name test car.java. I go to command prompt, Java C test car.java. Okay. And now Java test car. I just run it 100. So that value 100 is coming. Okay. Now let's get back. We were talking about instance methods. So again, as I told you, we'll make this private. And we'll have 2 methods, one to access the value, one to assign a value to it. Now again, come to this below code, car C1, C2, C1 is equal to new car, C2 is equal to new car. But now since that speed is not public, it is private as we made it private. Okay, I cannot directly assign a value to it. If I want to assign a value to it, I'll have to call that set speed method. So let me call it C1 dot set speed 100. Okay. Similarly, C2 dot set speed 200. Okay. System.out.println C1 dot get speed. So I get the value of speed variable and I print it. Okay. So again, the question comes, what do you think it's going to print? What do you think it's going to print? Again, if you think it's going to print 100, you're correct. It's going to print 100. See here. Save it. Recompile. Rerun. It's again printing 100. Okay. So now let's try to justify why these methods, set speed, get speed, why all those methods that you have given in car class, why are they called instance methods? Why are they called instance methods? So again, coming back, now this time what we are doing, C1 dot set speed inside the bracket 100. When we are calling set speed method on this instance, when we are calling set speed method on this instance, it is setting the value of its own instance variable, Similarly, when we say C2 dot set speed 200, C2 dot set speed 200, it is setting the value of its own instance variable to 200. Then when I say C1 dot get speed, when we are calling get speed method on this instance, it is getting the value of its own instance variable, own speed variable, and returning the value. That's why we are getting 100. So means what? When you are calling these methods, they are operating on their own instance data. When you are calling these methods, they are operating on their own instance data. That's the reason they are called instance methods. Now again, common sense. If instance is not there, instance data won't be there. If instance data is not there, how can these methods operate? They cannot operate. So means what? You can call an instance method only when you have an instance. And when you have an instance, how do you call this instance method? Reference to that instance dot. So I hope it justifies why they are called instance methods, because when you're calling these methods, they are operating on their own instance data. That's the reason they are called instance methods. Also, since they are operating on their own instance data, if instance is not there, instance data won't be there. If instance data is not there, these methods cannot operate. So you cannot access them. So if you want to access these methods, you need an instance. And when you have an instance, how do you access these instance methods? Reference to that instance dot. So one thing to keep in mind, to access an instance variable and to access an instance method, it is necessary that you need an instance. Only when you have an instance, you will be able to access instance variables and instance methods. And how will you access them? Reference to that instance dot. So I hope it clears about concept about instance variables and instance methods. Now next, let's try to understand what are class variables and class methods. What are class variables and class methods? Again, come to this speed variable. Again, I'll make it public. Since public, I won't need these two methods, get and set. I comment these two methods. In fact, not only I make it public, now this time I'm also going to make it static. Okay. I'm also going to make it static. Okay. Public static int speed. Okay. Now after doing this, I again come back to my code here. Car C1, C2, C1 is equal to new car, C2 is equal to new car. Now since that speed is public, I can directly assign a value to it. C1 dot speed is equal to 100. Similarly, C2 dot speed is equal to 200. And now system dot out dot println C1 dot speed. I am accessing and I am printing. Okay. So now what do you think? What do you think it's going to print? What do you think it's going to print? This time, if you think it's going to print 100, you're wrong. You're wrong. It's not going to print 100. It's going to print 200. 200. See the result. I just save it. I go to command prompt. I compile it. I run it. See this time. The result is not 100. It's 200. Now let's try to understand why is so. Why is so? Okay. Why is so? Remember this. The moment you declare a variable to be static, it is no more. It is no more individual copy for individual instance. It is no more individual copy for individual instance. It is one common shared copy for all the instances of that class. One common shared copy for all the instances. It won't be an individual copy for individual instance. Something like this. See here. we have created two instances. C1 is referring to one of them, C2 is referring to another. But this time that speed variable is not individual copy for individual instance. It is one common shared copy for both the instances. Okay. Now when I say C1 dot speed is equal to 100, this variable, the value will be set to 100. Then I say C2 dot speed is equal to 200, the same variable, the value will change to 200 because it's a common copy which is being shared between both of them. So when I say C2 dot speed is equal to 200, the same variable value will change to 200. And when I say C1 dot speed and I access it, that is going to show you the value of that variable, and definitely it's going to print 200. It's going to print 200. Okay. One common shared copy. Okay. So that is what happens when you declare a variable to be static. The moment you declare a variable to be static, it is no more individual copy for individual instance. It is one common shared copy for all the instances. So you know what we say? It does not belong to any particular instance. We say that it does not belong to any particular instance. We say it belongs to the class of the instances. It belongs to the class of the instances. That's the reason it is called class variable. Class variable. Now again, it's common sense. Does not belong to any particular instance. Does not belong to any particular instance. If it does not belong to any particular instance, the question is, should we require an instance to access it? Should we? No. No. Why should we require it? It does not belong to any particular instance. So why should we require an instance to access it? We don't require an instance. We don't require an instance. We can access it without an instance. How can we access it without an instance? Class name dot car dot speed. So even if I don't have any instance of car class, then also I can access the speed variable. How? Class name dot car dot speed. See here, let me show it to you. Imagine if I don't create any instance, comment, okay. Still, I did not get it. Then also I can access that speed variable. Something like this. Car dot speed is equal to 150. And then I can also print it. See what system dot out dot println. Okay. In fact, I write another line. System dot out dot println car dot speed. I access it and print it. I can do this. See, I'll compile and I'll run it. It's working. So you don't require an instance. You can access a class variable without an instance. How? Class name dot. If you have an instance, you can access it in both the ways. You can access it as reference dot also, and you can access it as class name dot also. Both the ways you can access. But then Java recommends you to always go for class name dot. Even if you have an instance, Java recommends you to go for class name dot. Okay. And anyway, let me also tell you one reality, the truth, which very few programmers know it. Okay. If you have an instance, you can access it in both the ways. You can access it as reference dot also. You can access it as class name dot also. Let's say if you access it as reference dot, let me tell you, even if you access it as reference dot, when compiler compiles that line, he will replace that reference dot with class name dot. This is a reality. This is a reality. And you know, this reality which I'm telling you may come in very handy to you in some rare cases, this information. Okay. But anyhow, once again, I repeat, the moment you declare a variable to be static, it is no more individual copy for individual instance. It is one common shared copy for all the instances of that class. That's why we say that it does not belong to any particular instance. We say that it belongs to the class of the instances. And that's the reason they are called class variables. Now, since it does not belong to any particular instance, why should you require an instance to access it? You don't require. You can access a class variable without an instance. How? Class name dot. If you have an instance, you can access it in both the ways. Class name dot also and reference dot also. But then Java recommends you to always go for class name dot. Also, I told you the reality that even if you do reference dot, it will anyway be substituted with class name dot by the compiler while he compiles. Okay. But now some more knowledge. Remember here when we were talking about when you give a call to the constructor, It provides storage space for instance variables. Instance. It does not provide storage space for class variables. It provides storage space for instance variables, not for class variables. So now in our case, that speed and gear both are static, both are class variables. So constructor is not going to provide a storage space. This time, this is the case. When you're creating object of car, it will just provide storage space for clutch, brake, accelerator, which are instance variables. You are creating another object, again, clutch, brake, accelerator. Only instance variables is what the space is provided by constructor. In fact, even you can understand if it provides, if constructor provides storage space for class variables also, then it will become individual copy for individual instance. But class variables are not individual copy for individual instance. They are one common shared copy. Constructor does not provide storage space for instance variables. Then the question comes, who provides a storage space for class variables? Class itself. Class provides storage space for class variables when class is loaded in memory. And remember, class is loaded in memory only once. Class is loaded in memory only once, even before first instance is created. Exactly when first time class is referred at runtime. When first time class is referred in runtime, class is loaded in memory, and class is loaded in memory only once, even before first instance is created. And he's the one who's going to provide storage space for class variables. Now, since that class is loaded in memory only once, these variables, class variables, they get created only once. And that's why it is one common shared copy for all the instances. Now, if you're wondering, what is this class loading? What is this class loading? Now, if you look at your class, car class, okay. A part of this data, you have these methods, and in this methods, you're going to write instructions. You know, when object is created, I told you, ये होता है. This is what is object. This is what is object in memory. This block is of what? This block is of what? This block is of instance variables. Only instance variables. That block is what is object. But those methods that you have written in class, the instructions that you have written in class, don't you think even they need to be loaded in memory? Because those instructions are going to operate on this data. Even that instructions have to be loaded. That instruction getting loaded in memory is what is called class is loaded in memory. Instructions are loaded only once. Data copy is created again and again. Every time you create an instance, copy of data is created. Instructions are loaded only once, because those are the same instructions which are going to operate on different copies of data. So instructions are loaded only once. Class is loaded only once. Now, if we look at our code, our application is going to start from main method. Now, if you look at the first line of code, car C1, C2, when this line executes, don't you think that car class will be referred? The car class will be referred, yeah, at runtime. As soon as this car class will get referred, car class will get loaded in memory. Not only will it get loaded in memory, it will provide storage space for those class variables, speed and gear. So when this line executes, car class will be loaded, speed and gear variables will get created. Since they are created, now you can access them. You don't even need an instance. And that's exactly what we are doing, car.speed. I hope it makes it clear. So once again, the moment you declare a variable to be static, it is no more individual copy for individual instance. It is one common shared copy for all the instances of that class. That's why we say that it does not belong to any particular instance. We say that it belongs to the class of instances. That's the reason those variables are called class variables. Now, since they do not belong to any particular instance, why should we require an instance to access it? We don't require an instance. We can access a class variable without an instance. How? Class name dot. If you have an instance, you can access it in both the ways. You can access it as class name dot also. You can access it as reference dot also. But then Java recommends you always to go for class name dot. Even if you have an instance, it recommends you to go for class name dot. And that is how you access a class variable. But I also told you the reality that even if you do reference dot, don't forget the reality. Compiler, when he compiles, he's going to substitute that reference dot to class name dot. Okay. Also, you understood who provides the storage space for class variables? Class itself. Constructor provides the storage space for instance variables. Class provides storage space for class variables. when class is loaded in memory. Class is loaded in memory only once. Only once. Instances are created again and again, but class is loaded in memory only once. And that also, it is loaded even before first instance is created. Even before first instance is created. Exactly when? When first time class is referred at runtime. So that is how it is. Okay. So all static variables are what are called class variables. So now if you look at this in Java, global variables word not used. If these variables are non-static, then they are called instance variables. And if these variables are static, they are called class variables. Global word not used. Similarly, whatever methods you define in a class, which are static, all the static methods that you define in a class, they are called class methods. Okay. Non-static methods are called instance methods. Static methods that you define in a class are called class methods. Now let's try to justify why static methods are called class methods. You know why? Because from a static method, you can access anything which is static. You cannot access anything which is non-static. From a static method, you can access anything which is static. You cannot access anything which is non-static. From a static method, you can call other static methods. In a static method, you can operate on static data. You cannot operate on non-static data. You cannot call non-static methods from it. So what we say that in a static method, we can operate only on static data. We can operate only on static data, and static data is nothing but class data. So we can operate only on class data. Since we can operate only on class data, these methods are called class methods. Okay. And again, you know, class data exists even if there is no instance. So means class methods can operate even if there is no instance. So means you can call a class method even if there is no instance. How? Again, class name dot. If you have an instance, you can access it in both the ways. Class name dot also and reference dot also. But then Java recommends you to always go for class name dot. Even if you have an instance, Java recommends you to go for class name dot. Again, the reality is, even if you do reference dot, it will be substituted by class name dot by the compiler. So that's how it is. Okay. But now, the last thing which I told you, that from a static method, you can access anything which is static. You cannot access anything which is non-static. You know, when we tell this to our students, most of the students, it happens that they misinterpret it. Misinterpret. I don't want you guys to misinterpret. So I'll be giving some more elaborations on it. Some more elaboration. Let's see. File, new, Java. Now imagine this. Class X, Y, Z. Okay. Inside, I declare int I, non-static variable. So means it's an instance variable. I declare an instance variable int I. I also define an instance method, public void m1, and inside that method, I is equal to 10. Okay, I set the value of I to 10. In fact, before I move ahead, one thing to observe, that I is an instance variable. Just now, a short while back, what I told you, that to access an instance variable, you need an instance, and when you have an instance, how do you access an instance variable? Reference to that instance dot. Reference to that instance dot. But now I'm currently accessing I. Have I done reference dot I? No, I haven't done it. So the question is it correct? Can I directly do I is equal to 10? Or should I reference dot I is equal to some reference dot I? Is this correct? Yes or no? I is equal to 10. What do you think? Yes, it is correct. You can do that. Okay. Why? Because you are accessing I within M1 method. M1 method and I both are members of the same class. One member wants to access another member He doesn't need a dot operator. Doesn't need a dot operator. Only this privilege is for members of the same class. If one member wants to access another member, he doesn't need a dot operator. But someone from outside this class, if he has to access, he has to do reference dot. He has to do reference dot. Members of the same class don't need a dot operator. Now, if you're wondering why that special privilege that a member of same class, if he wants to access, he doesn't need a dot operator. Why? For a simple reason. Try to understand. The criteria is that to access an instance variable or to access an instance method, an instance is required. Instance is required. That's the criteria. Okay. Instance is required. Now, tell me this I is equal to 10. This line of code, where have we written? In M1. When is this line going to get executed? When someone gives a call to M1 method, then only this line will execute. Okay. Let's say you want to call this method. Okay. If you want to call this method, since it's an instance method, don't you think you'll have to first create instance of this class XYZ? Because this is an instance method. So if you want to access it, you will be creating instance of XYZ, something like XYZ X is equal to new XYZ, and then X dot I, maybe let me put it public class X Y Z demo. Inside I again give a main method, public static void main string args square brackets. Now let's say I want to call that M1 method. It's an instance method. To access an instance method, I'll have to create an instance. So I first create object of instance of XYZ. XYZ X is equal to new XYZ. Okay. And then X dot M1. Okay. That is how I'm going to give a call to that M1 method. Now, before calling M1, what I did, what I had to do it was creating object of XYZ. So someone who has to call M1 is going to create object, is going to create instance of XYZ. So that criteria, that object has to be created, instance has to be created, gets automatically fulfilled. And that's why a member of the same class doesn't need a dot operator. This object will be created, M1 method will be called. As soon as M1 method will be called, what M1 will do, it will set the value of its own instance variable I to 10. Okay. So someone who's calling M1 is creating an instance. So that instance creation, which is a criteria, gets automatically fulfilled. And that's why this guy, member of the same class, doesn't need a dot operator. But as I told you, someone from outside, he needs to create an instance and he needs to access it by reference dot. Anyway, going ahead. Now let's say I give one more method inside, public void M2. And this method, let's say, is giving a call to M1. Again, M2, M1, they are members of the same class. So if M2 wants to access M1, he doesn't need a dot operator. He can directly call M1. Okay. Okay, I save it. My public class is XYZ demo. So XYZ demo. Okay. Now if I compile it, it compiles successfully. XYZ demo dot Java. Okay. Compiled successfully. But now if we make a little change, if I change this M2 method, I make it static. I make it a class method, public static void M2. Now, from a static method, you can access anything which is static. You cannot access anything which is non-static. Okay. Now, M2 is a static method. And from M2, we are giving a call to M1, and that M1 is non-static, not allowed. This line of code will lead to an error. From a static method, you cannot access anything which is non-static. See here, I save it, I recompile. This time, I'm going to get an error. Here it is. Non-static method M1 cannot be referenced from a static context. You cannot call non-static method from a static method. Okay. So he's going to give you an error. Try to understand why is Java not allowing it. Why it is giving a compiler error? Imagine if Java wouldn't have given an error, if compiler wouldn't have given an error on this line, if it would have allowed, it would have allowed, let's imagine if it would have allowed, if it did not give an error, then what would have happened? Runtime, there would have been a problem for Java. How? Just try to understand. Now, since M2's static method, anyone who wants to call M2, doesn't need to create an object of XYZ because it's a class method. To access a class method, you don't need an instance. You can access class method, class variables without an instance. So let's say if I want to call M2 from outside, do I need to create this object? No, no need, not needed, not needed. I can directly call that M2 method by class name dot xyz dot M2. Okay, this is how I'm going to call it. Now imagine at runtime, when this line executes, when M2 method gets called, since it is internally giving a call to M1, M1 will get called. M1 is trying to set the value of I. But where is I? Has I been created? No. Why? Because I is an instance variable. When will it get created? When instance will be created. There has been no instance created. So no I variable created. If there is no I variable, how can the value be set? Don't you think Java will get into trouble at runtime? Yes, it will get into trouble because there's no I variable. Whose value to set? Okay, that's why it knows it will get in trouble at runtime. So forget about runtime. At compile time itself, Java halts you. It does not compile this line. It will not allow you from a static method. It will not allow to access anything which is non-static. That's why at this line of code, we are getting an error. As you can see, again, non-static M1 cannot be referenced. So from a static method, you cannot access anything which is non-static. But if I make a little change, yes, if I make a little change in this code, it will get compiled. You know what is the change that I make? See here. In this, what I do, before calling M1, I create an object of XYZ. XYZ X is equal to new XYZ. I create an object, and now X dot M1, this will get compiled. This is going to get compiled. See here. Now it will compile. Sorry, it's a semicolon. I gave colon. Save it. Compile. See, it compiled successfully. Compiled successfully. This thing can be done. You cannot, from a static method, you cannot access anything which is non-static directly. But in a static method, you can create an instance, and in that instance, you can access instance variables and instance methods. That you can do. Why? Because at runtime, like here, if I want to call M2, I'll call it. It's a static method. So I'll call it without creating an object, directly class name dot xyz.m2. As soon as this line executes, M2 method will get called. Inside M2, first what we are doing, first we are creating an object of XYZ. Now, don't you think as soon as that object gets created, that I variable will get created? And now in that object, when we give a call to M1, that M1 will set the value. Instance methods, they operate on their own instance data. That M1 will set the value of its own instance data I. Everything will fall in place. So that thing can be done. So you know what is the message that I want to give you? When I say that from a static method, you cannot access anything which is non-static, you cannot access something which is non-static directly, you cannot access it. Okay. But in a static method, you can always create an instance, and in that instance, you can access instance variables and instance methods. That you can do. In fact, if we again come to our c.java, if you see here, c.java, look at this main method. Look at this main method. Isn't it static? Yes, it is static. It's static. It's a static. That main method is a static method. Okay. Inside this main static method, see here, a1.m1. Are we calling that m1 method? Are we calling that m1 method? That m1 method, is it static? No, it's non-static. So from a static method, we are calling non-static methods, but we are not directly calling it. First, we have created instances, object of A, object of B. We have created object of A, instance of A, and in that instance, we are accessing that instance method. That we can do. Okay. So I hope this concept is clear. So never be under this misinterpretation. From a static method, you cannot directly access something which is non-static. But in a static method, first you can create an instance, and in that instance, you can access instance variables and instance methods. So that is it. Now, another few things that I'd like to tell you. Again, imagine in this code, if I make a little change, okay. If I make a little change, I change, okay, before I make a change, we had seen this giving us an error, a1.m2. Once again, we'll see it, a1.m2, a variable declared as of type superclass can refer to subclass object, but it can only be used to access those members in subclass which it inherited from superclass. So on this line, we had discussed we'll get an error, cannot find symbol method m2, a1 of type A. Compiler says a1 is of type A. I'm going in A and I'm searching for m2 method. I'm not getting it. See that error coming? See that error coming? Java C.java. Okay. A1.m2 giving us an error. Cannot find symbol method m2, variable a1 of type A. So I told you we'll have to either comment it, or we can say b.m2. That will compile if we say b.m2. Why? B is of type B. Go in B. Is there a method m2? Yes, it is there. So compiler is going to compile it. Anyway, let's say I comment it. I save it. Now I compile it. Now it compiles successfully. When I run Java C, hi, hello. This is the output that I get. Okay. A1.m1. This line of code. When A1 is referring to object of A, that M1 method of A is getting called and we are getting hi on console. Okay. Then at this point of time, A1 equals to B, the reference changes. A1 starts referring to object of B. And now when A1.M1, it is calling that M1 method of B and we are getting hello. So that is the output, proper output we are getting. Now I make a little change in this code. I make a little change. I make this method static. Okay. Also, M1 method in B also, I make it static. Okay. M1 in A, I make it static. M1 in B, also I make it static. Now, if we see this code, look at this code. My question is, if you can start thinking, my question is, after making this change, are we going to get the same output, hi, hello? Or do you think it's going to change? If it's going to change, if you that is what you feel, what do you think? What do you think? What change? What different output we are going to get? Either it's going to be same or it will change. If it will change, what different output do you think it will come? I don't know what. If you can think about it. Anyway, let me tell you. Okay. Let me tell you. This time, the output will be different. It is not going to print hi and hello. This time, it's going to print hi, hi. See here. Let's recompile and run. See here. Recompile, run. Hi, hi. Now, if you're wondering, why did it change? Why are we getting hi and hi? So listen, when compiler, try to understand. Forget runtime. First, we are talking about compile time. Compiler, when he compiles this line of code, a1.m1, what is his duty? He's going to check whether that m1 method is there or not. Where is he going to check? In class A. Why? A1, he'll figure out. A1 is of what type? It is of type A. So let me go in A and check whether m1 method is there or not. Yeah, it's there. Compiler is going to find out. Yeah, it's there. And he's also going to find out, oh, it's static. It is static. Oh, m1 method is static. Remember, I just told you static variables, static methods. You can access them without an instance. Class name dot. If you have an instance, you can do it in both the ways. Class name dot also and reference dot also. If you access reference dot, that is what we are doing. We are accessing that m1, which is a static method. Reference dot, it will be substituted by class name dot by the compiler during compile time. Now, since m1 method, he went and searched, he found it, and he found it to be static. Since he found it to be static, he's going to substitute this reference dot with class name dot. capital A. Why of type capital A? Because A1 is of what type? A. Okay, A1 is of type A. So he will substitute that because compiler works on data types. So he's going to substitute it with capital A dot M1. Okay. Similarly, on this line of code, again, when he compiles, A1 is of what type? It is of type A. Let me go in A, check whether there is a method M1. Yes, it is there. Again, it is static. Oh, it is static. So let me change this A1 again to A. Okay. He's going to change this to capital A. Why? Because he works on data type and A1 is of type A. So he's going to change. So A dot capital A dot M1 capital A dot M1 is what he's going to do. So at runtime, that M1 method of A at both the places will get invoked. And that's why the output that you're going to get at both the places is high. Did you understand? Okay. So that's it. Okay. That's what I told you. That knowledge that I gave you will come in handy in some places. So here, unintentionally, maybe there was a mistake. We wanted M1 method of B to be invoked, but unfortunately M1 method of A got invoked. So it's always a better practice. We should adopt what Java says, what Java recommends. I told you, Java recommends that whenever you are accessing any static method or static variable, you always keep it a practice. Access it as class name dot. So instead of reference dot, if we would have used class name dot, and at this point, if we wanted to invoke M1 method of B, don't you think we would have done capital B dot M1? Correct. So it's a good practice, that recommended practice, that whenever you are accessing a static variable, class method, you should always keep it a practice to access it as class name dot. Okay. So anyway, this was to prove what I told you. So I remove this static. I bring this program to its original shape as it was. Okay. Remove it. And here also, I remove that A, make it A1 as it was. Okay. Save it. Okay. Now, look at this main method. It's static. Okay. It's static. Now the question comes, let's try to figure out why main is static. Why main method has been made static? Why? Okay. Let's try to understand. There is a reason that main is static. Now imagine, don't you think to start an application, at least one object needs to be created? To start an application, at least one object needs to be created. But the question is, how to create that one object until and unless we don't start the application? To start an application, at least one object should be created. Once that one object gets created, it will create two more. Those two will create four more. Those four will create 8 more objects. Objects. They'll start interacting and the application will start working. So to start an application, at least one object needs to be created. But the question is how to create that one object until and unless we don't start the application. Don't you think it's a deadlock? It's a deadlock. To solve this deadlock, that main has been made static. Imagine if main was not static. Imagine if main was not static. Now in our case, let's consider our case. In our case, our application is supposed to start from main. And imagine if main is not static. If main is not static, main needs to be called so that our application starts. Main is non-static, means it's an instance method. Just now you learned to invoke an instance method, you need an instance. So to invoke main method, object of C, instance of C is required. So the minimum one object which we require to start an application in our case is object of C. Do you agree? Main method has to be called. It's a non-static method. To call it, object of C is required. So in our case, that minimum one object which is required to start the application in our case is object of C. Okay. But the question is how to create object of C until and unless application does not start. Deadlock. That's why to solve this deadlock, this main has been made static. Now if main is static, it's a class method. Static method, class method. To call a class method, to access a class method, instance is not required. So we don't require object of C to invoke main. We can directly invoke it. Anyone can directly invoke it. class name dot main, capital C dot main. That is how. And exactly that is what JVM, Java Virtual Machine, that is what it does. To start your application, what JVM does directly, class name dot main, C dot main, and that is how your application starts. So that minimum requirement, that minimum one object has to be created, that requirement no more remains because the main is static. So that is how JVM is going to do it. Class name dot main, C dot main, it's going to call that main method, and that is how your application is going to start. So I hope you got it, why main has been made static. I again repeat, to start application, at least one object needs to be created. But to create that at least one object, application needs to be started. It's a deadlock. To solve this deadlock, main has been made static. Since main is static, our application is going to start from main. And since main is static, object is not required. That main method can be invoked without an object because it's a static method, because it is a class method, class name dot, and that's what JVM does, class name dot main, and that is how your application starts. So that's the justification of why main is static. Now, if we come to this line of code, system.out.println, let's try to understand this line of code. System, it's actually a class in Java library. It's a class, S capital. Okay. It's a class in Java. So system.out. So here, if you note, class name dot out, class name dot out. I'm accessing this out. How? Class name dot. So one thing is sure, that this out is static. That's why we are accessing it as class name dot. Static what? It will either be a static method or it will be a static variable inside system class. That out is either a static variable or it is a static method inside system class. Okay. What do you think? That out, is it a static method or a static variable? What do you think in system class? If you're thinking it's a method, you're wrong. It's not a method. Why? Because if out was a static method in system class, we are accessing it. Accessing a method is calling a method. So if out is a method, we are calling that out method. Any method, even if it is taking no parameters, then also open parenthesis, close parenthesis, while calling, those parentheses have to come. Have I given out parenthesis, parenthesis? No, I have not used those parentheses. Means this out is not a method, it's a variable. So out is a static variable declared inside system class. That out variable, which is a static variable declared inside system class, it is declared as of type print stream. So if I show you in system class how that out variable has been declared, if I show you, this is how: public static print stream out. That is how that out variable has been declared inside system class. That out variable name, it is of type print stream. Print stream is a class in Java, again in Java library. See, it's the name of a class, P capital S capital. Out is declared as of type print stream. It's a reference variable declared as of type print stream. It is static and it is public. Not only that out variable has been declared, it's also been initialized. It's also initialized to refer to an object is equal to new print stream. It refers to print stream object. That out variable declared inside system class. It's a static variable of type print stream. It's public. Not only it's declared, it is also initialized to refer to a print stream object. So out refers to a print stream object. Within print stream is a method. In print stream class, there is a method println. It's an instance method. In print stream class, there is an instance method println. We are calling that method. That out is referring to print stream object. Inside that print stream object, we are calling that println method. When you call that println method of print stream, whatever argument you pass, it will print that on console. So in our case, it is going to print that hi on console. So println is an instance method in print stream. When you call that method, it does the job of printing on console. So that hi will get printed on console. In fact, the last thing, that println method in print stream is overloaded. Overloaded means there are multiple println methods. name same, they differ in parameters. One println takes a string, another println takes a int, another println takes a char. So multiple println methods. Since they all do the same job, they all do the same job of printing. That's why the name is same, but they differ in parameters. So I hope you understood this line of code. Once again, system is a class in Java. Within system class, out is a class variable, static variable, declared inside system class. It's a reference variable declared inside system class of type print stream. That out is declared as of type print stream. Not only it has been declared, it's also initialized to refer to a print stream object. That println is an instance method. It's an instance method in print stream. When you call that method, what that method does, prints it on console. And as I told you, that println method in print stream is overloaded. Multiple println methods, they differ in parameters, but they all do the same work, same job. What they do, they print it. They print it on console. Okay. So this line, I hope it's clear, the syntax. Okay. So I think we'll stop this session here. We'll meet in the next session. And in the next session, we are going to discuss history of Java and the architecture of this language. So see you in next session. Bye for now.